Hello everyone, welcome to the problem solving session from magnetism part. This is problem number 77, chapter 28 from Raising Halide Walker. In this problem we say that the electron moving towards x direction with a speed 100 meter per second through a uniform electric and magnetic field. It means that the electric and magnetic field is not going to change over here. The magnetic field is directed into the base and has a magnitude 5 Tesla. Now we have to find out the electric field in unit vector notation. Fine, let's start. Since it said that the electric field and the magnetic field is uniform over here, so they will not change over here. It means that the electron will move at a constant speed. The direction of this speed of the electron we can write down v is 100 meter per second towards the x direction, and we can assume that the magnetic field is given, which is b into the base. We will assume, say that x is z. This is the positive z-axis. Then into the base or into the screen over here would be basically negative z-axis. So that's why we can write the direction of the magnetic field would be minus 5 Tesla k hat. Fine. Since the electron is moving at a constant velocity, we can say that the net force onto that electron would be basically the 0. Now we have to find out actually the direction of these forces. The magnetic force onto that electron, we can write the magnetic force, we can find out using that formula, which is Q into B cross B. V is the velocity and the B actually the magnetic field at the location of this electron. And electrostatic force we can write down would be Q into E. So the Lorentz force or the total force over here, you can write the total force F would be Fe plus Fm, right? And these two forces, we have to find out the direction of these two forces actually, since the net force on this electron must be equal to 0, since the electron will move at a constant speed or the constant velocity. To find out the direction of the magnetic force, we are going to use that right hand rule. What is that rule? You will put your forefinger towards the first vector, which is the speed or the b over here of the electron, and place your palm in the direction of the second vector, which is that magnetic field. Now I place my hand, if you closely observe in the inset, I put my forefinger in the direction of the velocity of the electron and place my palm in the direction of that magnetic field, which is into the screen. Now if I rotate my rest of the finger from first vector to the second vector, so that's mean from velocity towards the magnetic field, then my thumb would be basically towards the upward direction. That's mean the magnetic force onto that charged particle would be towards the upward direction. But this convention actually for that positive charge. Now since we are using a negative charge, which is the electron, I'll just flip down the direction of this force. So that means the magnetic force over here onto that electron would be basically the downward direction. So this will be the direction of the magnetic force onto that electron. So this is actually magnetic force. Fine. To balance this force, your electrostatic force must be towards that upward direction if the electron wants to move in a constant velocity. So that means this would be the direction of that electrostatic force. To make the force towards the upward direction of an electron, the electric field must be towards that downward direction, since we know that a positive charge moves in the direction of the electric field and a negative charge moves in the opposite direction of the electric field. So that's why since it's an electron, the force on that electron must be towards the opposite direction of this electric field. So that's why the electrostatic force will be towards the upward direction. Then these two forces must be going to the cancel out. In that case, the electron will move at a constant speed. Fine. So that means we can say that this net force or the Lorentz force onto that electron would be basically the zero. We can write the electrostatic force, which is Fe, plus the magnetic force, which is Fm, must be equal to the zero. Or we can say Fe must be equal to negative Fm. So that's mean electrostatic force would be equal to the negative of the magnetic force. Now the electrostatic force we can write, which will be the Q into E, right, where Q is the charge of that electron, and the magnetic force we can write Q into big V cross B. Now we can cancel out this Q. We can write in that case E would be basically minus V cross B, where V is the velocity of that electron and B is the magnetic field at the location of that electron. Fine. Now I'm going to plug in that value of speed of the electron is 100 I hat into magnetic field is minus 5 k hat. I choose that into the place actually negative z direction. Now if you do some calculation, what you will find out this minus is going to the plus, is going to the 500 I cross k. This is actually the properties of the unit vector properties. Now we can find out that I cross k would be basically that negative j, right? So it would be negative j. So this is would be actually that it's electric field at the location of that electron in unit vector notation. So this is actually that answer of this question. Thank you very much.